Hello and welcome back to the second part of Chapter 8, Adding and Subtracting Polynomials. Let's go ahead and get started with just a little bit of review. Remember that these are all monomials. They are either numbers or variables or a product of both. So the degree here would be, now careful because this is not a exponent of a variable. It is just a exponent of a number, so it's really 100 in disguise. So the degree here would be 0. How many exponents here? 1. Remember, you have to add up the degrees of each exponent, or add up all the exponents to get the degree of 6 here, because again, we added those numbers. And then finally, the degree of this monomial would be 5. And now these are not monomials, and let's go through and give all the reasons. Well, here we are dividing by n. You cannot have n on the bottom of a fraction. Then the plus sign, we are adding. You cannot add. So I'm going to say adding. Then we have a exponent of a variable. Can that be allowed? No, it is not. So I'm going to say exponent. And then finally, how about a negative exponent? Can you have a negative exponent? No. And so I'm going to say no, negative, and if I can fit it in, exponents. Perfect. Now, I did not give you the names before, but I'm going to give you the names today. Again, it's not that big of a deal if you can't remember quartic and quintic, but I do need you to get through 1 through 3. Remember, 1 is linear, 2 is quadratic, 3 is cubic, and then 4 is quartic, 5 is quintic, and when you get past 6, then it just turns into the 6th degree, 7th degree. So here, what is the degree of this polynomial? Well, our highest degree is 4, and so it would be a quartic polynomial. Now again, the degree is the greatest degree of its terms. We have its terms and the greatest degree are important. Now when we are given these, let's go ahead and rewrite them in order of greatest to least in descending order. So it's 4x squared y squared plus 2x squared minus 3x. The degree of this polynomial would be 2 plus 2, which is 4. The classification is quartic. And how many terms do we have? We have 1 term, 2 terms, and I'm going to underline them. We have 1 term, 2 terms, 3 terms. So how many number of terms do we have? We have 3. Now, the degree of the polynomial. How big is this polynomial? I'm not going to rearrange it this time. Here we have 3 plus 1 is 4. Here's 3, here is 2, here is 3. So the degree of the polynomial is 4. The classification of this polynomial, well, it would be 4. So again, it would be quartic. And then how many terms do we have? We have 1, 2, 3, 4. So your terms are just like monomials, added or subtracted together. So we have 4 terms. Now again, the degree of polynomial, we have 3 plus 3, which is 6. We have 1 plus 1, which is 2. And we have 3 here. So the degree here would be 6. The classification would be trinomial because we have 3 terms. And how many number of terms? We have 3. All right, coefficient is the number part of the term. So the coefficient here would be -4. The coefficient here would be 5. Coefficient would be 125. Again, it is in what is in front. It is multiplied, but what is in front of your variable. And then here, what is in front of your variable, your coefficient would be -3/4. All right, as a fraction, it is -3/4. Leading coefficient is the coefficient in the first term, hint, first term in standard form. First thing we want to do with these is rewrite them to put them in standard form. They are not in standard form because they are not in descending degrees of exponents. So since this has 2, I'm going to write 4x squared plus 5x, because now this is 1, plus 4 because there is no exponent. So my leading coefficient is whatever is in front of that variable. So it's 4. And then again, we have 6n squared, then minus 2n, and plus 9. The leading coefficient now is 6 because it's what's in front of the variable with the highest degree. So let's try some examples here. Starting with 1, the very first thing, remember the very first thing I want you to do is to rewrite it without the parentheses. So we have, and I'm going to switch my pen, we have h squared plus 4h minus 4 plus now 5h squared minus 8h plus 2. Alright, I just took everything out of the parentheses because that was a plus. So now let's go ahead and combine like terms. I'm going to start with h squared. I have 1h squared there. I have some more h squareds here. Is that how many h squareds I have? Yes, it is. So it's plus, and so it's 6h squared. What else do I have? I have plus 4 h's. Here I have minus 8 h's, so when I combine them, it goes into negative 4h. And then finally here I have, remember your sign in front, negative 4 and positive 2, so it is negative 2. Now with number 2, look at what kind of sign we have, please. We have a negative sign. So I'm going to drop the first part down, 9b cubed minus 13b squared plus b. Now remember, it's a minus, so when I distribute here, when I change all my signs, I have to change that one, and that one. So it's going to be plus 13b squared plus 5b, and then minus 14. Now, let's look at all our like terms. Do we have any b cubes? No, we do not, so it's just 9b cubed. Then, we have a negative 13b squared. Do we have any other b squareds? Yes, we have a positive b squared here, and it's 13 of them, so those are now gone. Moving down the line, I have plus b here, I have some more plus b's here, and so b plus 5b is plus 6b, and then finally we have negative 14. So here would be your final answer. A couple more here. Please remember, always look at the sign in the middle of the parentheses. It is a negative sign. So what we have to do now is go drop the first ones out, 6x squared minus 5x. Now we have to distribute that. Please remember to distribute that to change all your signs. So now it's negative 2x squared minus 3x plus 2. So here we go again. Does anything match up with a 6x squared? You bet. We have a negative 2x squared, so we get 4x squared. What else do we have? We have a negative. Please see that negative right there. And a negative 3x. We combine them to get a negative 8x. And then finally, what do we have left over? This lonely 2. So we add it right there for your final answer. And one more with number 4. Now we have a word problem that states a Major League Baseball team divided into 2 leagues during the period of this, the attendance NNA in thousands, so remember the answer is going to be in thousands, at National and American League baseball games can be modeled by these 2 equations where T now is the number of years since this, about how many people attended Major League Baseball games in 2000. Well, the first part we have to do is we have to figure out how many people went to the baseball games, or actually Major League Baseball games, and Major League Baseball games are made up of the National, represented by N, and the American League. So the very first thing that we have to do is add those 2 together. So I'm going to add N plus A together, and N is going to be negative 488 8t squared plus 5430t plus 24700. And now I need to be careful and start writing this a little bit better so my handwriting doesn't get too sloppy. And then we're adding that to a negative 318t squared plus 3040t plus 25600. Now we combine those. Combining all your like terms, I have this guy. Do I have any other t squareds? And I have this guy. Remember, those signs are both negative, so when I combine them, it turns into a negative 806t squared. What else do I have? I have some t's here. That is a plus. That is a positive t. I have some t's here, which is another positive. That, when added together, will give me plus 8470t. And then, finally, add your numbers together, there and there, to get plus 50300. And now, so that is Major League Baseball right there. This equation that we have right here is the Major League Baseball, or how many people attended Major League Baseball all together. But now we are asked, where T is number of years, how many people attended Major League Baseball games in 2011? Well, how many years are from 1995 to 2001? There are 6 years, so I'm going to take that 6 and plug them in anywhere I see a T. So I'm going to go negative 806, and now I'm going to put that 6 in for T squared plus 8470, plugging it in for T, plugging 6 in for T, plus 50300. Now if you want, you can plug this all into your calculator right away, or go piece at a time. So it's going to be a negative 29,016 plus 50,820, and then finally 50,300. You punch that all in to get 72,104, and that's how many people. And please note that that answer is in thousands. So to recap again, we found the Major League attendance by adding the National and American League together. We simplified to get this, and then we had to figure out what T was by subtracting the years. Plug that T in, added them all up, punched it in the calculator to find 72,104, and I should even write 1,000 just to note that we are measuring in thousands people. And that is it. Good day.